brain. Okay? And I'm showing you this because we're going to spend the first easily half hour to 45 minutes, and after that I'll be like, okay, we're done with the first part. And you're gonna be like, so I want you to understand a big picture. Then we're going to cover B and C just like that. So now I don't want you to lose the forest for the trees idea, right? So this is a forest, but we're going to spend a lot of time on this tree right here, a lot of time on this tree right here, and then a little on that. Okay? So I just don't want you to lose the big picture here, so that's why I have this. So this is the first thing to go for. This is the first thing to understand and study. Clear? Okay, something else. Embryonic development, you see on page 1. None of that. None at all we have to know about embryonic development. It's something that's nice to know. It's something that's interesting. But with regard to testing material, it just adds a bunch of terms and things that I just don't want you to focus on. I'd rather you focus on the adult brain. Okay? Just like we focus on the adult spinal cord. So we skip that as well for the spinal cord. We'll skip it here as well for the brain. I just haven't gone through and deleted it from the notes. So I'm telling you. Okay? As far as the only thing I'm really on page 1 to be concerned with is just the general description of the brain. Obviously it's a wrinkled mass of an organ, as you can see here. Kind of a pinkish gray tissue. And at least anatomically, we have the cerebral hemispheres. So we have the right and left hemispheres that form the large portion of, you imagine a mushroom, the cap of the mushroom. That's what we call the cerebral hemispheres, or cerebrum. That's the same term. So cerebrum or cerebral hemispheres are the same thing. We're going to be talking a lot about this big portion of the brain. Okay? Now we're going to be talking about it, not just different regions of the superficial parts, like this part right here has a different function in this part, and this part, and this part, on the superficial surface. But we're also going to go deep into it. And we're going to look at what's deep to what you can physically see here, what's immediately to that, and then what's even deeper than that. We'll spend a lot of time on the cerebral hemispheres or the cerebrum. Okay? In addition, it's hard to see here, but there is the diencephalon is here. Okay? And that's a portion you can see a little easier later on when we get different color coded. When you see it in yellow, it doesn't make a lot of sense right now. So don't freak out too much about it. Okay? And then the last part is the brainstem. Okay? Which you can see parts of it right here. You just call this the brainstem. And there's actually 3 components that make up the brainstem. Now, as soon as that brainstem technically exits the foramen magnum, it's technically called the spinal cord. But there's no true line in a body. You can't pull out the spinal cord of the brain and say, oh, that's the part that's the spinal cord, that's the part that's brain. It's just technically right there where it passes that hole. Right? So it kind of gradually becomes the spinal cord. So you see pictures like this, which is just basically showing you again how the brain forms and the spinal cord forms. And we're going to skip all this up here. And really, this is not a picture that'll be on your exam, but this is the first example of what the adult brain really looks like. Okay? So there's a lot of terms that are in here that I'm not going to be holding you responsible for because they're terms that deal with embryonic development, like telencephalon, for example. So don't worry about all those things. If it's not a term you've heard, it's not on your big master picture here, don't worry about it. Okay? So it talks about those different terms, the ones that are already on the big picture on page 2. And it just tells you basically how some of these come about. But as I said, for right now, I wouldn't worry too much about it. We'll get to them in just a little bit. What I want you to do, I do want you to focus on is on page 3, ventricles. So you should know in general what a ventricle is, but not different types of ventricles. There's actually different names for these. For example, the 3rd and 4th ventricle. I don't care that you know the 3rd and the 4th. I just care that you know in general what these are. So what is a ventricle? Well, it's a hole. It's a cave. It's a potential space for cerebral spinal fluid. Now, most people think the brain is a solid mass of tissue. They're wrong. It actually has caves where fluid flows within it. And we call those the ventricles. And that's where these are. So you can see these from the lateral and from the frontal, actually anterior view here. And you can see that, oh, okay, they form very distinct passageways. And actually, it's very difficult to tell here. But this connection right here allows the cerebrospinal fluid to go around the outside of the brain as well. And so we'll talk later on about the movement of cerebrospinal fluid, and you'll see it goes around the brain, down the cord, and even inside the brain as well. And that helps nourish the tissue. And actually regions in here you'll see later on make cerebrospinal fluid as well. It's actually in the ventricles. Okay? This is a picture to be familiar with. You'll see this again. Okay. When you're dealing with the adult brain regions, okay, the adult brain regions, there's 4 of them. If you look on the bottom of page 3, it says right there, adult brain regions. Cerebral hemispheres, diencephalon, brainstem, cerebellum. That's exactly what you see here. Just give you the big picture. So if you look, the adult brain, we can divide it into 4 different parts. We have the cerebrum, or what's called the cerebral hemispheres, the left and right, together are called the cerebrum. We have the diencephalon, we have the brainstem, and we have the cerebellum. 4 parts. We can then subdivide the cerebrum into the cortex, the white matter, and the basal nuclei. And when I say subdivide, I mean we're going to go deep into it. Okay? We'll cover that in just a little bit. The diencephalon, there's actually 3 parts here. And then the brainstem, there's 3 parts as well. So we'll come back and just want to point out the 4 parts. Okay, dealing on the surface. So the superior surface, we're going to talk a lot about just that top layer of the cerebrum, or cerebral hemispheres. There's about 6 cell layers, or 6 somas, 6 layers of somas. And that does the majority of the work of the brain, at least what we consider the conscious brain. When you say, oh, where's your brain? Well, what they're really talking about is the cerebral hemispheres, and specifically the cerebral cortex, the cortex being the outside part. So we're going to be looking at the surface, or the cortex, of the brain right here. Now, if you look at this, it's folded, it's wrinkled, and there's actually names for that. So the elevated region, like you see here, is called a gyrus, or gyri, for plural. And then the lower area, or a little cavern, or whatever you want to call it, and it looks like a little creek, right, is called a sulcus, or sulci, plural. So we have gyri and sulci, gyrus and sulcus. And so we would name all of these. We'd say, okay, this is a gyri, this is a gyri, and this in between, this is sulcus. Now there's other technical terms. When you get into deeper crevices, we would call those fissures. We're not going to get into that in this class. Okay? So we talk about different fissures throughout the brain, or large fissures that separate it. Don't worry about that. Just know gyri and sulci, and you'll be okay. Right. You know the terms that are in bold, but the longitudinal fissure, for example, the transverse cerebral fissure on page 3, I wouldn't ask those kind of things, even though they're in bold. Okay, on top of page 4, I want you to put a star next to that top sentence. It says several sulci divide into, or each hemisphere rather, into 5 lobes. 5 lobes. So each hemisphere, so you have your left hemisphere, you have your right hemisphere, and each hemisphere is divided into 5 lobes. You can see those here. Okay? So we have the frontal, the parietal, the occipital, the temporal, and the insula. Okay, what's the insula? Well, we'll get there. The first 4 are named by, well, the bone. It's very simple. If you've already memorized the bone, you should be able to memorize the lobes. And so we have this lobe here that's in the front of the brain we call the frontal lobe. Right? We have the lobe here, this purple area, all this purple, that's considered the parietal lobe, again, by the parietal bone. Same with the occipital, the temporal. The one that's kind of hard to understand is the insula. And you literally have to pull the brain apart a little bit to get in there. And that's called the insula. So you should be able to describe or tell me both on a picture as well as labeling, or spitting out 5 lobes. If I ask you to name the 5 lobes, you should be able to do that. Okay? Okay. Now we're going to get into more details about these regions of the brain in just a minute. So we talked about 5 lobes, but in reality, this part of the brain right here, it does a specific function. This part of the brain right here does a specific function in this as well. But again, we're talking about the surface, okay? We're going to be talking a lot about the surface, but then we're also going to be talking about something deeper. So if you look here, it says, again, on the top of page 4, it says with 2 little stars, each cerebral hemisphere has 3 basic regions. A superficial cortex of gray matter we call the cerebral cortex, which is what we're going to be talking about in just a few minutes. It's that first 6 cell layers or so, and it's really what does the majority of what you call brain activity in the brain. An internal white matter, and then islands of what we call basal nuclei. And I'm going to show you a picture. I'm going to jump ahead here so you can understand what I'm talking about. Okay, we're jumping way ahead. If you were to cut the brain, the cerebral hemisphere, can you see the gray area right here? That gray area are the cell bodies that are going to be in the cerebral cortex. But if you go deep to it, you're going to see areas of white. See the white? That's the white matter. So what are those? Well, those are all the connections. So you have all the cell bodies, all the soma, on the surface of the brain, and then you have all the wires connecting them deep to it. Does that make sense? The wires connect each other, and the wires connect to other parts of the brain, and even the wires might go all the way down to the cord, which is what you can kind of see in that picture up there. We'll get to this in a little bit. I just wanted to give you that idea. The last thing is, okay, so we have the gray area of the cerebral cortex. We have the white matter that's deep to that, but then even deeper, we have areas called nuclei, or basal nuclei specifically. What's a nuclei? What's a nucleus? At least with respect to the brain. It's an area where you have concentrated cell bodies, right? So it's gray matter, and you can see some of these here, okay? So these are areas we call basal nuclei. So there's actually dark areas, dark staining areas within the cerebral hemisphere.
Within each lobe of the, or
each lobe,
not lobe.
each hemisphere.
Okay.
Yes. Does that make sense? Okay, we're gonna back up. We're going to talk a lot about just the cortex, just the surface, and then we'll come back to the white and the basal nuclei in just a few minutes. Okay, so the cerebral cortex. Cerebral cortex on page 4. We're going to be talking about motor control and sensory control and something called an association area. Those are the big things we're talking about. Motor, sensory, and association area. So the cerebral cortex, okay, the surface of the brain, if you want to call it that, or at least the hemispheres, as I said, is about 6 cell layers thick. It's only about 1/8 of an inch in diameter, but it actually makes up the majority of 40% of the weight of the brain, at least of the hemisphere. That's because it's all the bodies, all the cell bodies are there. That's where all the living cells are that are controlling, or at least thinking and seeing light, doing all those interpretations. They're all there on the surface of the brain there. I say this acts as the executive suite of the nervous system. Well, this is where our conscious mind is. You're going to see that in just a few minutes. It's all on the surface of our brain. So we're going to have on page 5, you can see that the cerebral cortex contains different functional areas. We're going to see motor areas, we're going to see sensory areas, and we're going to see association areas. So let me just give you an example of how that would work. Okay. Okay. So your book, as opposed to the book I used to do, does not do a great job with labeling. Meaning there's a lot of things that I may say that aren't necessarily on this picture. If that's the case, we don't have to find it for the lab exam. If it's not on the picture, you're good. Okay? I think the book did you a disservice, but that's my opinion. So there's just a couple of things that they didn't label. And I'll show you those, but I wouldn't hold you responsible for them. Okay? So motor areas. Well, we talked about descending tracts already, right? So we have a cell body that's on the top of our brain, and it's going to send down an axon, right, called an upper motor neuron, and it's going to go somewhere in synapse, somewhere in our brain stem or somewhere else, and then that's going to go and connect to, let's say, our skeletal muscles out here, right? So that's a motor control. We have a neuron that's dedicated to motor. Where do we find that? Well, we find it right here. the primary motor cortex. So you can see this gyri right here, this gyrus, that again on both hemispheres, you have it here and here, okay? Control motor function. So the skeletal muscles specifically that we are doing. So every movement we do with our skeletal muscles is controlled right there. That's the actual neuron that's firing, leading to that movement. Does that make sense? This is actually how it works. So again, if you take that hemisphere, right, from superior to an inferior view, these are the different neurons that control different parts of your body. And what you're going to see here is two things, and I'll use this term. It's contralateral and it's upside down. What does contralateral mean? Well, it means that your left brain controls your right side of your body, and your right brain, the right hemisphere, controls your left side of the body, because there's a crossover, what we call desiccation. Okay. So you can see here, and by the way, it's upside down too. So our feet, our toes are here, and our head is way over here. So it's upside down and contralateral. And you're also going to notice that we have a large percentage of neurons dedicated to certain parts of the body, a lot more than others, which makes sense. So you think, wow, why are the legs so short when the hands are so big and the face is huge? Well, think about the movements. Think about the skeletal muscles that are involved in that, to give you very precise control of your fingers and give you very precise facial features, facial expressions, and being able to speak and talk. Well, that has to be accounted for by skeletal muscles, and we dedicate a large percentage of those to those movements. And so you can see how that's done. Okay. So this is the primary motor cortex, and they show it here in blue. Okay. Primary motor cortex. Now, this is where the cortical spinal tracts are, or the pyramidal tracts. So cortical spinal, I think you didn't have to memorize these things, but that's where they are. The most common tract, the one everybody usually memorizes, is the cortical spinal or the pyramidal tracts, because the neurons, the actual cell bodies, are right here. Okay, now what you don't see here is something called the premotor cortex on page 6. Premotor cortex. And what they're not showing you in the picture, because the picture is not very good, is right here. There's a lobe right here, which is not even really drawn very well. And it's right next to this one. So this is called the premotor cortex. I would never have you label this on an exam again. Okay, it might be on the lecture exam, but never on the lab. But it's right here. And so this is where we have repeated or repetitious things. So you can imagine that these right here, the cell bodies right here, are going to be connected to these. So it's going to be a very intimate relationship between the neurons here and the neurons here. So that if you learn something like how to play a piano, right, where you have learned repeated actions, those repetitious things are going to be learned here. We're not going to get into learning and memory and dreams and stuff in this class. I wish we could. Okay? But that's where it happens. So repetitious things. Okay? So pattern motor skills is another thing. It's that playing a musical instrument or even typing. You know, type 60 words a minute. Well, the reason you can do that, and in fact, if we hooked your brain up to a bunch of sensors and you were typing, you would see this guy glowing like crazy. Okay? Because that's what's actually helping control these. So this is directly connected to the skeletal muscles, but this right here is helping out that with repetition. Broca's area, right here in pink. Broca's area is part of the brain, hemisphere I should say, that helps move the muscles of the tongue. And so it helps you speak. And in fact, again, if we were to hook electrodes up in your brain, when you're talking, that would start to glow. Or if you're getting ready to talk, it would start to glow as well. So this is the area that helps you speak, Broca's area.
Expressive speech, right? The process expressive language?
Yeah, verbal. Yeah, I don't think it's sign language, I think it's verbal. It's of the tongue. I don't think they have this frontal eye field. They don't have it labeled here today. No. It's okay. Okay, something that gets people confused sometimes. There's a difference between moving your eyeball and vision. Okay? Moving the eyeball is simply physically moving an eyeball. It has nothing to do with light, in seeing light. It's just moving it. So the muscles that control that movement are actually controlled right around this area. It doesn't really show you here, but you would imagine right around where the eyeballs are, or roughly so, is where you would actually see what they call the frontal eye field. So the frontal eye field is involved in movement of the eye muscles. But actual vision is way back here, in the primary visual cortex. I'll come back to that in just a few seconds. As far as sensations, we have a primary somatosensory cortex. So we have the primary motor cortex. We also have a primary somatosensory cortex, and that's right here. Another big one to remember, and it's shown in deep purple in your picture. So this is the field. So this is where we're going to receive from ascending tracts, right? So we're going to be receiving input from ascending tracts in this general region. And not surprising, very similarly to what we saw before, with the motor control, with sensory control, we have contralateral and upside down. So again, we feel with our feet way up here in the superior surface, and as we move inferior, we move actually up in the body. It's actually the opposite. And again, the left side of the brain feels the right side of the body, and vice versa. Okay? And not surprising, just like we saw with muscle control, the area of the body that needs the most sensation, for example, hands and face, have a large amount of space dedicated to that. That's what you see here. You good so far? Okay. Let's talk about this idea of an association area. So it says right there, somatosensory association cortex, which cortex or area is fine. We use the term association. I used to call it association area. Somatosensory association area is right here. So it's right next to here. We have this is called an association area as well. It's right next to it. So what is this exactly? Well, if I were to go in my pocket, okay, I have in my pocket, well, I wish I had different change, I don't have it, okay? Let's say I have a dime, a penny, a nickel, and a quarter in my pocket. I could go in my pocket and feel the different coins. And I could probably, with a pretty high degree of accuracy, pull out a quarter every time. Why? Well, because I feel for the ridges, right? I feel for the shape, I feel for the general size, and various other things, the thickness. So those are all things that I can interpret and understand as being a quarter. Make sense? Okay. The same thing would be true if I looked at you guys. I can identify you by name. Why? Because I recognize certain things about you, right? I can put a bigger picture to my sensations. You getting a better idea where we're going? So an association area is able to put a bigger picture on sensations. So this area right here is taking the information from here and putting it all together and saying, oh, okay, well, we see a red thing that's kind of shaped like a flower and it smells like a rose, so it must be a rose. So it takes these kind of big things and puts them all into a general picture, and again, we get the overall sensation of, we get the overall perception, I should say, of what we're looking at. Talk about some other ones. Again, we're talking just the surface here. So on page 8, primary visual cortex. So right here, we're going to be talking about the eyeball next week. And the optic nerve. It's going to carry the information from where we see, that's light energy or photons, what we actually see, gets sent through the optic nerve to the primary visual cortex. That's the first place it goes to. But you'll notice right here we have the visual association area. Well, this is going to help this area interpret, give a bigger picture to what we're actually seeing. So we're going to see red or green or whatever the case may be, and we're going to be able to put that all together and give an overall feel for what we're looking at. Again, I can see someone's face, I can see that's a flower. So that's the association area versus the primary visual cortex. Okay. Hearing, auditory. We talk about auditory, we're talking about hearing. So we have the primary auditory cortex, and actually is shown here. Here. Yes, here. Sorry, it's not labeled. Yeah. So that's the primary auditory cortex, is where when you hear things from the vestibular cochlear nerve, we'll learn about that a little later. When things go down that nerve from hearing, they will synapse right here, and that's the primary area where we receive hearing. At least the comprehension of that. And then of course we have an auditory association area. So we can tell the difference between someone screaming and someone singing. There's a difference. Right? It's all sound, but it's our perception of that. And for some, screaming is singing. Right? It just depends on your taste. Okay. Wernicke's area. Wernicke's area is right here in yellow. And this is an area that's kind of interesting. It's the area of the brain that's involved in sounding out unknown words. So if you have a 9 and 7-year-old boy like I do, you know those areas of the brain are active right now because they're constantly trying to figure out new words. Like, how do you say this, Dan? I don't know. Sound it out. Right? Okay. And they'll process it, right? They'll know other for words, and they can take that information and sound out new words, and that's down here with Wernicke's area. Again, how do they know this? Well, they hooked up electrodes to your brain, and pow, that part of the brain glowed. So, now, that's not always true. I'm not going to get into all the history of the brain, but a lot of times the reason we know these areas is because people got damaged in these areas. Okay? So, if you hit yourself in the head right here, and all of a sudden you can't, pronounce words very well, maybe that part of the brain's involved in that pronunciation of words. And that's actually what happens in a lot of cases where people were shot in the forehead right here, and it split the brain apart. You don't have communication between left and right. Or if you damage the front part of the brain right here, Phineas Gage, ever heard of Phineas Gage? So he damaged the front part right here, and his personality changed. They figured out, oh, it's the frontal lobe right here. It's following personality. So things like that do happen. But that's more of a psychological thing. We won't get into it. If you had psychology, you've learned some of these things before. Olfactory cortex, so smelling. Okay, that area you're not going to see. Why? Well, it's usually in the insula. Well, they kind of show it here. Kind of goes up in the insula. So olfactory cortex, it actually is in the insula. It's the association area you're seeing. So again, olfaction is smelling. We'll come back to that term later on. Gustation is tasting. Olfaction is smelling. So your olfactory cortex is involved in smelling. So we have about 10,000 different odorants we can perceive, we can detect. And that information gets sent to the cortex, which you can't see here, it's embedded and buried in here. And it's then interpreted as different odors. And we can take that overall odor and determine, okay, is that a skunk or is that a flower? And then later on, we can actually process it even more. We'll get into it just a little bit. Okay, is that a pleasant smell or not? And is this something I'm going to remember? Always remember what a skunk smells like the first time you smell it, right? We'll talk more about that later on. So gustatory cortex, again, is in the insula. We can't really show it here, but it's involved in tasting. Visceral sensory area, also in the insula. So this gives you your feel of, oh my gosh, I got to pee so bad, right? Full bladder. So those kind of visceral perceptions. Bless you.
Bless you.
And then vestibular cortex, again, also in the insula. So equilibrium. Equilibrium is one of those senses people don't always think about. They think about vision, they think about hearing, right? But when I say name the senses, no one ever says balance or equilibrium. Well, it's one of the senses. We'll learn about that next week.